Okay, this is problem number number 8, sorry. Number 8 on chapter 11, section 1. And for this problem, just pause the video and read. Take a minute to read. Okay, here the claim is that the company claims that the distribution in each package is like that: 12% red, 22% orange, 14 yellow, 9 brown, etc. Right? And if you click on this icon shows the color count for in a package, right? In a randomly selected package, and they count the number of red candy, the number of orange candies, yellow, etc. So this is what actually happened. That's the observed. Okay, and the claim or the expected count is to be 12% of 100. It's not hard to do that, right? We don't need a calculator. 12% of 100 is just 12. 22% of 100 is just 22. And 14, etc., etc. 14, 9, 25, and 18. So this is the question. We want to test the claim that what it was counted actually follows what the manufacturer or the company claims, right? Okay, so again, I need you to set up this on L1 or on L2. We have done this thousands of times before, so I'll go a little bit quicker. So let me see, start, go to test, and start, edit, number 1, and I will just edit these numbers: 11, 26, 7, 12, 27, and 17. On this side, what I'll do is type the expected quantity for each category. So it's 12, 22, it's 12, enter, 22, enter, 14, enter, 9, enter, 25, enter, and 18, enter. Okay, so far this is what we have for the observed and expected column. Okay, so we go to start again, we go to test, to the right side until you see the test, and you scroll down until you find a goodness of fit option. So let me go down, 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 till I find something like that reads like this. Look. Okay, it says chi-square goodness of fit. I mean, it looks something like that. Okay, and we select this option. Okay, x square goodness of fit. We press enter. On the observed, make sure it's L1, expected L2. Degrees of freedom, well, we have 1, 2, 3, 4, 5, 6 categories. So degrees of freedom is 6 minus 1, which is 5. Okay, let me verify again. 1, 2, 3, 4, 5, 6. Yeah. So we write 5 here, and we can either press calculate or draw, whichever. Let me do this, select draw and click enter. What you see here on this on the calculator is the test statistic and the p-value. Okay, let me show you here the test statistic and the p-value. Look, well, in this problem they actually want the test statistic, right? They want this number 5.53. In this case, they want you to find the critical value, because as I said before, in this section they want to use the critical value method instead of the p-value method. The p-value method in this case, look, alpha is 0.01, alpha is 1%. okay? And the p-value is, let me round it up, like 3551. So this p-value is greater than alpha, so we fail to reject. When the p-value is greater than alpha, we fail to reject, right? This is the p-value method. But in this situation, they want you to use the critical value method. Read the chapter again, and you will see that there are two ways to test a claim, using the p-value or a critical value. So we need to go to the table, and with a degrees of freedom of 5, and with a 1% significance level, we need to find the critical value from the table. So let me move to the next page to find the table. Yeah, it was 5 and it was 1%. So if we follow that, my critical value will be 15.086. Let me see if that is correct. Yeah, that's the correct critical value. So that critical value goes here. Chi-square critical, I'm going to write it like that. It's going to be 15.086. Anything before that, we fail to reject. Anything after that, we reject the null hypothesis. And what determines if we fail to reject or reject is this critical value. And we need to compare the test statistics with this critical value. You see, the test statistic in this particular situation is in this region, right? It's in the fail to reject, okay? Because it's 5.553 is before 15. So do not reject or fail to reject, which is the same. And there is not sufficient evidence to warrant rejection of the claim. The claim, by the way, I should have done this at the very beginning, but the claim is that the proportions are as expected, right? Okay. Okay. So there is no sufficient evidence to warrant rejection of the claim that the color distribution is as claimed. Okay. So there is no sufficient evidence to disprove what the company claims in this situation. Okay. So that's how you do this problem.